This is about code signing. Everything about code signing and how not to use it. Many thanks to our sponsors. Again, these companies, these sponsors allow us to meet here and give us a great opportunity to learn. So thanks to them. My name is Raymond. I'm with Microsoft since 22 years now, and always worked in the space of DevOps, programming, operations, so something about platform automation. I'm active in the DSC community. So my main projects are the DSC workshop and M365 DSC. And Twitter handle and the GitHub page are listed there. So who should be interested in code signing and why? Software vendors, of course, IoT manufacturers, mobile app developers, but I think most people here are from enterprises. This is why you use PowerShell. This is why we are here. So why should you be concerned about code signing? Maybe a question to the audience. Who is using code signing already? Okay. So do you have a fully automated code signing process, or is it rather something that you do manually after you have copied stuff around? So who's doing it automatically? Fully automatically. Okay. A handful of people. Nice. Okay. That's the way to go. So what's code signing used for? To protect their intellectual properties, their company brand, and their end users, right? That's the theory. It doesn't always work. Let's dive into this. So what is code signing? We should be able to verify the software origin, but this only works if things are done correctly and if there is no breach, right? We will come later a little bit to the practical things, how code signing works. So ensure code integrity. So we know where the code is coming from and it can't be altered after the signing process, which means otherwise it wouldn't make sense to test the origin in the first place, right? So it is not possible to alter the code after the signature has been created. It usually enhances the user experience, not in our case, but if you are downloading software from a trusted publishers, you don't get these nasty warnings that you are maybe downloading malicious stuff. In the PowerShell space, we don't have these warnings unless we are using app locker, when software doesn't work at all, which is unsigned, or an execution policy, which I guess most of you have disabled on their server machines just to be able to work. So user experience is not the most important thing here, and combat malicious attempts. And this is kind of connected to this one here, right? So if we don't allow code to be tampered with or to be manipulated, then of course we are also trying to stop malicious attempts to change our source code. Yeah, this is in a nutshell what code signing is for. What is it not? So it does not fix coding bugs by default, right? So if you download signed software, it doesn't mean that the software always runs and has a very high quality. So also software quality is not guaranteed just because you use code signing. It should guarantee the coder's author, but does not always do. And we will see some examples when things went utterly wrong. And what do these names have in common? All these companies lost code signing certificate private keys. And then you ask yourself, how can it happen that a company like GitHub, I mean, there are definitely professional people working there, are losing code signing certificates, right? What happened there? Oh, D-Link even multiple times. So obviously there is something important in the code signing procedures and code signing processes that if you don't adhere to these principles and patterns makes you a risky person. So if you use code signing, know the risk that is involved with code signing. So if you don't do it properly, then you may even put an extra burden on yourself, on your company, on your reputation, as well as the end users. Good. And this is just a number. So organizations experience an average of 4 incidents involving the misuse of code signing keys and certificates. Another reason is you can also misuse a code signing certificate without losing it physically. If you grant people access to the code signing infrastructure that should not have access to, right? So we will also have a look at how to secure that. Good. So now we know what code signing is. We know what it is not, and we know that's a risky thing if dealt the wrong way. Don't sign code locally. And let's do a little demo about how easy code signing is. And it is. So what about the font size? Is that okay or okay? Almost. Let's do one more. Okay. And so it's a live demo. I hope everything runs as expected. It doesn't always work. So we just create a root certificate locally because I didn't want to invest 500 euros just to get a code signing certificate for myself. So here we are just using self-signed local certificates, which you should never do, of course. We will come later to the point where you usually get your code signing certificates from, right? So first of all, we are creating a root certificate, and then I'm creating 2 certificates for code signing using the famous new self-signed certificate commandlet, which works very well. And you can create a root certificate first, and then use the root certificate to sign the other certificates, right? So you can just simulate a trust chain like you get it from DigiCert or some other vendors. Okay, so if we do that, just calling the script. No feedback is always good feedback. That means we have a certificate here in Trusted Publishers. Let me get to my Zoom it. So we have a code signing for release and a code signing for test. So the best practice is that you sign pre-releases with a different certificate than your full releases. The full release, of course, the full release certificate is trusted globally and by your customers. The test certificate is only trusted within your test environment, within your organization. That means it's very hard to distribute. No, it's not very hard. It's easy to distribute test software, test releases to your customers, but it won't work because they don't have the certificate, right? So you have another extra layer of security by using a test and a release certificate. So I'm mostly working in the open source PowerShell space, and there we can't do that. So if we would use code signing, then we have just one certificate for the pre-releases as well as the full releases. But this is a best practice to have too. Okay, so that works. Let's go into the next demo script, which is sign locally. And this is no magic. It should be very easy for everybody to follow along. So we just get into our certificate container and grab a code signing certificate, the one with the name code signing test, right? And we store this in the variable test. Perfect. Hopefully it worked. If we have a private key, which we do, right, has private key, then we are be able to sign a script. The public key is for the verification, the private key for creating the signature. Okay, then we are creating just a very simple script in our current directory, and then we add a signature, and then we want to see the result. Obviously, it worked, right? So we're creating 2 scripts here. Let me follow the next ones. Works, and let's see the difference. So now we have 2 scripts, test and test with timestamp, and you can see the length is very different, right? So what happens what you should always do, always create a timestamp, because if you don't have a timestamp and your certificate expires, the code is not going to work anymore. If you use a timestamp authority to create a timestamp, then actually the code runs as long as you want, endlessly, because we know at the time of the signature creation, the certificate was valid, and therefore we are trusting it, unless it is being revoked. If you are revoking a certificate, of course, then it completely loses the trust. But even then, a timestamp makes sure that your code is working if the code signing procedure was done before the revocation. Because the revocation usually has a date timestamp as well. So if someone recognizes the breach, then you can revoke the certificate, let's say 1 week before the breach, to make sure that no code was maliciously distributed with a code signing certificate, right? So timestamps are very important. What they do is they take the hash of your script plus the timestamp, sign it with the timestamp certificate, and add it to the script as well. And therefore, it grows in size. Okay, so it works. What's the problem with the procedure of signing the code using the easy-to-use commandlet? Where is it? There, set authenticate signature. The problem here is we need access to the private key. And if we have access to the private key, it is not guaranteed that the private key does not leave the machine or is not used by someone else who has breached into the machine, right? So going back to the slides. This is the flow, how it works. First of all, we are not hashing, or we are not creating a signature of the file, of the PowerShell script file. What we do is we first create a hash digest using a hash algorithm, and this one, the hash digest, is sent to set authenticate signature, right? Set authenticate signature goes to the local certificate store, retrieves the private key, and contacts the TSA, the trusted authority for getting the timestamp. And then it creates the hash, which is added to the script, right? And this portion here is very important because this enables a completely different way of signing code than it would be if we have to send the whole script somewhere else, right? We will come to that if we talk about Azure Key Vault. Good. Any questions so far? I think everybody has tested this once, right? So call the command, let's see that the hash is generated. Okay, good. So lessons from the demo. Better than bad code signing is no code signing, right? So if you use an unsecure way of signing your code, then you are predicting that you are creating secure or code in a secure way, that you have everything under control, but you don't, right? If you sign locally, that means that the private key is not secure. If your organization requires code signing, protect all your assets. So one asset is the private key, but there is more to go, right? Never do code signing manually as part of a trusted release pipeline for multiple reasons. First, for security, of course, because in this manual way, the private key is exposed. Scaling, it simply doesn't scale, right? Because if you want to fix a bug and then you need to search the person that has access to the certificate, then it delays the whole process of releasing something, right? So, a software release process with signing should be fully automated to be able to scale and easy to use, right? Because multiple teams want to distribute software, usually, and are in the requirement of code signing. So it should be something that is very easy accessible without any burden in the process, right? And we will see how this can work later. And of course, never allow access to the private keys. Is anybody using an HSM for code signing? Okay, just one, yeah. Good. How to protect your assets. So, there are multiple certificate types. They are technically all the same. IV, OV, EV. It's individual validation, organization validation, and enterprise or extended validation. And nowadays, only EV certificates are being issued, which means, and there are a lot of rules that are applying to EV certificates. And one rule is the private key has to be in a FIPS 140 level 2 HSM. So how does it work? It works like you are creating the private key within the HSM. Then the HSM creates a certificate request that you pass over to the certificate authority, like DigiCert or whatever. They are creating the public part, sending the public part back, so the certificate file with the public key, and you merge these things within the HSM. So even while creating the certificate, the private key never leaves the HSM. There is no chance, right? So that's the new way, beginning of June 2023. So still, many people use the old way. So if you use Azure Key Vault, for example, without an HSM, make sure that access control is implemented, that only a very small audience has access to the private keys, or better, no one has access to the private keys. You can give yourself access in terms you need it, and then at least auditing will catch any modification of the access control lists. Of course, we need timestamping, because without timestamping, we have no clue when a certain piece of software was signed. So, right, we don't know if it's still trustworthy. And what is very important, and what I don't see in many organizations, is centralized certificate inventory. So in large organizations, you have maybe hundreds of teams that use code signing. And every team is, or maybe half of the teams, is requesting code signing certificates from whatever vendor without the security team knowing about these certificates, right? So if you have a bunch of teams that do code signing the wrong way and nobody in the organization has a view on all these processes, then it's almost guaranteed that at some point in time something goes wrong, right? So an organization should know how many code signing certificates are used where and when. And that's important to have a centralized register of these certificates. And only then you can monitor and audit the code signing activities, right? So it was about protecting your assets, right? So you want to know when a code signing certificate is used in order to make sure that it was maybe used outside the normal release process by someone who should not have access to. So even if the private keys are protected, there are still risks. Good. And another thing is authenticate code before it is signed and released. And this requires that you protect the release process. You protect your main branch. It should be impossible to do any pushes or any commits to the main branch, because if it is, then you have no review process in place, right? So every change to code must go through a pull request. And of course, we need to have pull request policies in place. For example, we need to have at least 1+ reviewer, there are 2+ reviewers, right? That can check if malicious code or maybe buggy code has went into our product that then eventually gets signed and sent to customers, which is hurting our reputation, right? And this is something that happens, unfortunately, too often, never allowed to approve your own pull requests, right? Because you are the worst reviewer of your own stuff, right? So these are the important things that you want to have in place to make sure that code quality is high, and only code quality or code with high code quality is sent to the signing pipeline. Good. Good. How does it work? Signing keys with Azure manually. So still not the way good way. Let's have a look how we can use Azure Key Vault. First of all, we have to introduce our tenant ID, subscription ID, Key Vault. Then I'm connecting to my tenant. That's fairly simple. Okay. And what I can do now is I can take the certificates I have previously imported. Remember, my first script was creating 2 certificates, and it was also exporting the certificate as PFX files, right? And I mean, this is the mistake in the first place. If you are be able to have a certificate as a PFX file, then the private key was not secure all the time. So if you use EV certificates, this wouldn't be possible. But for demo purposes, it's fine. And then we can take these PFX files and upload them to Azure Key Vault. Okay. As this Azure Key Vault is non-premium, so there is no HSM behind it, we still can read the private keys if we have the necessary permissions. And this is how it works. So we are, I need my passwords for later. Okay. So what I'm doing here is I'm just filling in some default or some IDs to later connect to the Key Vault. Key Vault name, the app ID, the secret behind the app. So we are using app authentication to access the Key Vault. And what I still can do is I can get the Azure Key Vault secret as plain text. So as the global admin, I can just retrieve the certificate, including the private key, because it's not stored on the HSM. Let's see. That's the secret. Just some base64 encoded string. And we can convert the base64 encoded string into a byte array. And from the byte array, we can create an X509 certificate, right? And let's have a look how it looks like. The PFX certificate object, here it is. Our code signing test certificate. Do we have a private key? Yes, we do. Right, so we have retrieved the full certificate object from Azure Key Vault, including the private key, which is not how things should work, because then you can just store it on disk and move it wherever you want to, right? That's bad. Okay, so how can we sign something without having access to the private key? We can, because Azure Key Vault is like software as a service. It does not offer just storing the stuff. It offers you also an API to do all the cryptographic actions. And one of the actions is signing. So next thing is I'm creating a credential object from the app ID and the app ID secret, right? And then I'm connecting again to Azure Key Vault, this time only, not with my global admin, but with the app ID. And let's see if things still work. So I still can get the Key Vault certificate. Let's store it, $cert equals, right, here it is. But has private key? Oh, wait a minute. It's another property. It is certificate.has private key. No, right? So I still can read the public part of the certificate, which is totally valid, but I'm not be able to read the private key anymore. This is because, well, let's get into the error message, because if I want to use the as plaintext switch, then what we get is just an error message telling us it's forbidden. So no access anymore. And this is because we have in the Key Vault access policies, and my application Key Vault reader has only the permissions to get a certificate and to sign. So this is all this guy can do, right? And this can be utilized by the Azure Signing tool. So before starting the session, I've installed the tools, the Azure Signing tool. So what you can do then is create another script file, get the script file object, and then call the Azure Signing tool by feeding in the URL, the app ID, the secret, and so on, of course, a timestamp source, and tell the tool which files to sign. So what happens now is, let's see if it works. Fail to get certificate. Demo. Great. So do we have the certificates? Yes, we do. What was the error message? A lot of text. That was the old one. Let's see. Failed to retrieve. Please verify the name of the certificate and the permission. Sign test. But sign test is there. Button. Let's try to authenticate again. So creating the credentials. Do I have the secret still in here? Ah, wait a minute. Maybe I was using secret. Should be something else. It should be that string. So let's see. Let's create the credential object again. Let's connect. Works. But reading worked, so interesting. And then call the signing tool. That looks much better. Yeah, so obviously something was wrong with my credential string. Okay, so what we have done now is we have created a signature. So the signature was created remotely in Azure Key Vault. We added the signature to the file. And let's have a look at our file that was created. Test Azure Key Vault with a typo in it. And here it is. So we have a very small one-liner with a huge signature, right? So that worked. So what's happening here? Let's go back to the slides. So what we do is, again, we don't need to provide the full source code to Azure Key Vault, because you don't want to send all your intellectual property to a third party just for getting a signature. So what we do again is, and here it's important that we are only sending the digest to Azure Key Vault, right? We don't have access to the private key. So what we do is we ask Azure Key Vault with the get and sign operation. Here is my digest. Please do whatever you have to do to create a signature, given the certificate name. So Azure Key Vault gets to the private key, creates the signature, reaches out to the timestamp source for adding the timestamp or getting a signed timestamp and sending me back the signature. So that means Azure Key Vault will never see my code and I will never see the private key. So it's a completely separate environment. That's the way to go, right? So that means that all your users, who actually should be technical users, it should be a release pipeline that has access to the to Azure Key Vault, but the release pipeline does not need any permissions rather than the get, which is getting the public key, and the sign operation, which is revealing nothing but just the signature that Azure Key Vault created. So this is finally the only viable approach to make sure that your private key is not getting into the wrong hands. Very important, right? So if you do code signing, always follow this approach. And as we have learned, it's mandatory anyway, using EV certificates. So if you apply for an EV certificate, you need to prove to the certificate authority that you are handling the certificates in the right way. And you need to send a certificate request anyway, which is coming from an HSN. Right? Any questions regarding this so far? Actually, quite a simple process. And the next question is, how can we make it at scale? And maybe some of you have heard about the sampler project. It's from Gail Colas, a module scaffolding solution. And then everything happens fully automatically. So we do the build, the sign, afterwards the test procedure, and then also the release. So in an ideal world, the only thing you have to do is, let me get rid of all these changes here. In an ideal world, the only thing you have to do is do some change to your code. So let's go to source, let's go to public, get something. And what do? We are just adding a dot. Okay. So here's my change in the Git plugin, and we do a fixed error message. We are committing the change, and we are syncing it. Okay, and if we go back to the pipelines, then we will see that the pipeline was automatically triggered. Here it is. It usually runs 7 minutes, so a little bit too long. But let's go to the last one, which was 2 hours ago. And here we can see that we are first calculating a new version for the module. So the version is calculated automatically. It's not up to you to decide what's the next version is. It's being calculated using Git version based on the commit message. Then we are installing Azure Signing Tool, and then we are going into the actual build process. And the build process is just taking all the files and creating one huge module. This is happening here. Yeah, build nested module builder, and here is the signing process. So after we have created the module, we are reaching out to Azure Key Vault and asking Azure Key Vault to create a hash for each file that is part of the module, right? Here we go. And after this is finished, we are creating a NuGet package, and we are storing the NuGet package as an Azure DevOps artifact in the Azure DevOps database. That's it. So build finished, and signing is finished as well. The next step is we are going into test. So we are testing our code, in this case, even on multiple platforms, Windows PowerShell, then PowerShell Core on Windows and Linux. And if all this happened successfully, if the tests are green, then we are going into the deployment. And what do we see here? In deployment, we are publishing a new module to the PowerShell gallery, fully automatically. So it's nothing that you have to do. It's part of the release pipeline, which means that, remember, the pipeline was running 2 hours ago. Let's go to PowerShell gallery. PowerShell gallery. What's the name of my project? Come on. That one. And here we can see that 2 hours ago, who has downloaded this version? Interesting. Okay, and we can see that we have a new release. And let's install the release, and let's see if code signing has really worked. So what we do is, let's take this one here. Let's go to our PowerShell again. Okay. And that was a bit too quick. Let's see. Did something happen here? Documents, PowerShell, modules. There it is. It was downloaded. No, that's the wrong one. Let's delete that. And let's see again, because we should run into an error. Yeah, we want to install it. And it cannot be installed because the authenticate signature is not valid. Of course, because it was a previous release with different certificates. But we can always do a skip, which is skip and yes. Okay, so let's see. Here it is. Let's check the signature of one of these files. Does it work with... No, it doesn't. Unfortunately, dynamic zoom never works. Then the second screen is black. Let me go back to my property field. So obviously it worked fine, but as I'm not trusting the certificate, I've removed the root certificate, we're getting the error message, right? But signature is done, right? So, and this of course scales as well, because you don't even have to think about code signing. It's part of your release process. It will happen all the time. In this case, with a test certificate for pre-releases and with a full certificate for full releases, right? So it's pretty customizable what you want to have, right? And if you want to use code signing in a similar way, just use sampler, and I think next week we will update sampler with an additional task, and that's the task that is doing the code signing. So just some code similar to what you have already seen. Not very rocket science. And you can customize your code or customize the process in the build YAML document. So here we have a configuration block where you can put all the details that are required to find the right key vault, find the right certificate, and contact whatever time server URL you want, right? And I think then you have a very scalable, easy to use solution to get secure code. But as we've mentioned, secure your private keys. If you have done that with an HSM-backed Azure Key Vault, the next step is to protect your pipeline, right? If someone can access the pipeline who should not have access to, then of course this person can inject code into your signing process and do whatever this person wants to do, right? So it's as important as protecting the private keys to protect also your infrastructure that is doing the signing process, right? In this case, the Azure DevOps pipeline and access to it. Good. So, do's and don'ts, right? Very short summary, never allow access to private keys. And the only solution to that is really using an HSM. Otherwise, so the private key needs to be accessible sometimes. And this short moment of access could be misused. Then use branch policies. Never allow anyone to commit code into main without a peer review process. Don't sign code manually, because this is going to break anyway and is slowing down the whole release process dramatically. So it should be some part of the pipeline. Release your software in a CI/CD pipeline. I mean, this is anyway a very good idea, right? So if you need to release software on a regular basis, then a manual release process is really painful and also error prone. So automating the release process is very important, and always think about all your assets, right? So is there maybe any assets that you can't think of at the moment that if someone has control over it could inject something into your software release process, right? So securing the whole process is very important. References. This article was kind of knowledgeable for me. We have the Azure Sign tool, the .NET Sign tool. I think Azure Sign tool will be replaced in the long term by the .NET Sign tool, which is giving you much more features. Always, if you start a new module project, a PowerShell module project, reach out to Sampler to see how this whole release process can be automated, as well as the module design. And the session material is yet on this project with a very bad name, but I will move it to something else. Afterwards, I will archive it so that you have access to all the resources. Yeah. Any questions?
I was going to ask one, sorry. In your process, you set something along the lines of being compiling the module and bringing all the functions in and stuff. If you've got a module which has 100 files that get dot sourced in, say, one function per file or something, if you were signing 100 files and then periodically importing all those files, is there a significant performance penalty with that?
Yeah. So the question is, what do you do if you have a module that consists of a couple of hundred files? So it was pretty common, I think 5, 6, 7 years ago, that you download a module and each function was represented with one file. The problem with that is loading time, right? So if you need to load a module that comprises of 100 files, it takes a little bit of time anyway. If you also need to verify the hashes of all these files, it takes even more time. So what you usually do is you solve the problem not while loading the module, but while building the module, right? So sampler takes all these 100 files and creates one huge file, which looks like this. So I think I have never built it here on this machine, but thanks to module fast, it should be pretty easy to. What happens here? I think I need to build. No, not here. Use module fast and resolve dependency. And what do we have in the output folder is now a list of modules required to create to do the build process. And I think it's already finished. Is it? Yes. So here's my module. Let's clean up the screen. It's pretty hard to work with this font size. So this is my PSM1 file, the only PSM1 file. And you can see that it has markers in it indicating where the code was coming from. So here we have a class definition, another class definition, another class definition, a lot of class definitions here. And there is my first private function, right, coming from that file down to here, and then we're going to the next one. So it's a very simple merge process. We take all the files, put it into one PSM1 file, including markers to indicate where the stuff was coming from. For debugging purposes, it's kind of helpful, right? And then this problem should be solved. Konstantin.
So how does sampler interact with the keyword? So you have to.
Good question. So how does sampler know which keyword to contact? This was done in the YAML file, in the build YAML, right? In the build YAML, we have definitions about the key vault URL and the tenant ID and the application ID. Of course, it would be extremely bad if we write the application secret also in the YAML file in plain text, right? So if we go to our build pipeline here and go back to edit, and by the way, deployment has worked 11 minutes ago, yeah. And go here to edit, then where's my edit button? Oh, I'm not signed in. I was on vacation and all these. Yeah, it's me. Doesn't look good. What's happening here? So, let's try one more time. Here. That looks better. So if we go to edit, then what we can do here is click or set up variables. And these variables contain my app secrets. Also a GitHub personal access token, the PowerShell gallery personal access token, and the ones for Key Vault. And these ones are protected, so it's impossible to display them in a PowerShell session or extract them from Azure DevOps, right? So all the identification information is in the YAML file, which is not sensitive, and all the sensitive information goes into a variable that is protected. You can argue that maybe even the app ID should be protected as a variable and not in plain text. Maybe we are going to change that. Yeah. Any other questions?
What would be the best practice for on-premise environments? Maybe don't have a key vault, and let's say you're running GitLab with a Git vault, and you need access to the private.
So the question was, how can this be implemented in an on-prem environment? Get yourself an HSN, right? Thales, some other companies, they offer these things. And then you have exactly the same experience, maybe not as comfortable, because maybe the tools are not so easy to use. I've no experience with that, but the process is exactly the same. Azure Key Vault is then replaced by a hardware solution within the data center. Yeah. Other questions? Okay. Actually, the process is pretty simple, right? So it didn't take so much time to prepare the demo. I didn't face any weird issues, unexplainable things. So the whole process is pretty straightforward. Azure Key Vault works perfectly as expected. So yeah, try to change your process to a more secure code signing process. Good. Thank you very much.